Hello everybody, welcome to the presentation of our paper, Successful Circular Biobased Construction Initiatives, 5 Essentials from Case Studies. We are Myron Koster and Irene Schotenboer of Avans University of Applied Sciences in the Netherlands. The content of our presentation is as follows. We will start with introducing the problem and the focus of our study. Then we'll explain our method. Next, we'll present our results. You can already see the 5 essentials at the right side. Then we'll wrap up and look ahead. And finally, there is room for some questions. Well, the problem. The context of our problem is the current transition from linear construction to circular construction. Well, the necessity of this transition is clear and is also well addressed in the literature. But the point is that in practice, the transition is progressing rather slowly. It is still quite difficult to realize circular biobased constructions in an affordable way. And what we lack is knowledge and insight of how to realize affordable circular biobased constructions. Well, this forms the starting point of our study. In our paper, we focus on the initiative phase. And we do so because in this phase, crucial choices are made that affect materials and energy consumption during the construction phase, as well as throughout the whole lifespan of the construction. Also, the choices in this initiative phase affect the costs and benefits of the construction, not only financially, but also non-financially. And also this in the initiative phase, as well as throughout the lifespan of the construction. Okay, this brings us to the research question. Our main question is, what is essential in realizing affordable and feasible circular biobased constructions? And in order to answer this rather broad question, we asked ourselves, what are crucial decision-making questions in the initiative phase, and what are success and fail factors? And how did we go about? Well, we did case studies. We selected exemplary circular non-residential construction projects in the Netherlands, Belgium, France, and the UK. And more specifically, we selected cases in the Interreg 2Cs region because we received funding from this EU program. An important note here is that we regard this region as one region, and we did not compare the cases in these specific countries. So we studied 13 cases in total, and we made a selection of 8, which we studied in more detail. In total, we interviewed 21 people, all people involved in the initiative phase, so we collected first-hand experience from these experts, and we interviewed people in several roles. We interviewed people at top management and also project management and those involved in design. With regard to reliability, for the interviews, we developed a protocol, including questions and topics to ensure that all interviews were conducted similarly. And all interviews were recorded and literally transcribed to avoid any bias in the data. With regard to validity, the interviewees were directly involved in circular biobased construction projects, so we collected first-hand experience in the initiative phase. So we measured what we wanted to measure. And secondly, the questions and topics in the interview protocol are, of course, also directed at identifying success and fail factors. Well, however, one could argue, of course, whether our list of selected cases is representative for this region. Yet there were also practical aspects, including willingness to be interviewed. And this also affected the selection of our cases. Myron.
Yes, so when you look at these cases in detail, the following 8 cases come across. And I don't want to go too detailed with these, but there's one specifically interesting because all the 5 essentials were present there. And that's the Emergus Clinic in the Netherlands, in Zealand. Then if you look at where they are applied, then here you find an overview of the different essentials that apply to the cases. And you see that mostly 2 or more essentials apply, and on the left side you find colors in the cases, and these refer to like specific interesting things to mention. So for the Emergus Clinic, there's something interesting to mention about affordable reuse, and for the Science Museum about flexibility, And these are highlights in the white paper. So that's why these colors match with it. Then we dive into the first of the 5 essentials, which is affordability. And it's about cost-effective and inclusive reuse. And the main question you can ask yourself here is how to make reuse cost-effective in current and future applications. And the things that make initiative more successful here is that if they can make use of social labor in organizations, or be clever about the design that makes it affordable. Because if you look at the spending on materials and on labor, then about 60% is captured in labor. And maybe even a bit more, because this material side is often also including labor at the production side. So labor is an important element. And if you reuse components, you can try, and that's the other success factor, to save as much embodied labor as possible. In this way, you can use a component and spend less labor on it while working on it. And that's also something you can take into account in the current design, so that at a future reuse stage, you can reuse a complete wall, for example. And then failure factors. So that would be reusing materials once, so using these donor building materials, but then in a way that they cannot be reused again. So try to set them up in a way that also in the future they can be reused again. And then the other fail factor is a fixed planning, because if you make use of reused materials, it's a bit more unpredictable, because sometimes the quality is worse than expected, sometimes it's better. So you need some flexibility in the planning to cope with this. Then flexibility. So the main question here is how to make a construction flexible in line with current and potential future usage. And success factors here is developing scenarios. So what can happen to this building? What will it be used for? What can it be used for? And take into account that most businesses only own a building for 25 years. So also looking a bit ahead, what other applications could be there is very much worthwhile. And then being smart about use cases without over-dimensioning. So for example, you could have a building of 2 floors and already be prepared to make it a 6th floor building, but that might be a bit too much. And then you're using a lot of materials in the foundation that might not even be necessary. So it's always good to be considerate here. And then if you look at failure factors, it's about merging building layers. So for example, putting the installation in the floors and foundation. And this foundation has a lifetime of, let's say, 100 years, and installations only have a lifetime of 20 years. So by combining the two, you lose a lot of lifetime there. So keeping them separate is a good thing to do. And the other thing is making use of non-demountable connections, such as glues. So making them demountable and remountable, that's the next step, is very much worthwhile. Then the third essential, passive. So how to stay cool and healthy with bio-based materials. And the main question is here, how to benefit passively from bio-based materials in the design. So what can you already apply in the design so that your HVAC systems or other systems have to do less work? And what you can do to do that successfully is to build in a vapor open way using these bio-based materials, but also using things like dynamic shading elements or things that provide more shade when it's very sunny. And then you can also look at making a business case out of absenteeism and productivity gains. Because if you look at the revenues in an organization or the costs in an organization, it's mainly related to people. So if you make sure they can work productively and stay working, then it's a good thing. And looking at your HVAC and maybe controlling it with CO2 is a very good basis here. And there's still a lot of research to be done to see how bio-based materials also contribute here. But from practice, we know it can make the feel of the building more comfortable. And then failure factors is not even considering passivity. This is really something that people don't naturally consider. So there's some group around passive building, but a lot of initiators don't even consider it. So that's quite a pity. Then we move on to the fourth essential, integral. And that's about continuously reflecting on the circular and bio-based benefits. So you can first calculate your business cases and the advantages it has and make decisions there, but then you have to work that out. And then the question not to ask yourself is, what budget do we need for the upfront investment? So most initiators look at the upfront investment and use this amount to see what sort of building they can make. But there's a lot of cost associated with operations that are often not taken into account. And as an example is the Venlo building, the Venlo Stadhuis, one of our cases. And there they looked at the absenteeism and the health factors, and but also at energy. And energy became the most concrete because there they saw that the interest on the loan they could take was so low that the operational cost reduction was way higher. So looking at the life cycle and cash flow, they decided to invest more in order to reduce their operational costs. So a success factor, one of them is making these cash flow calculations. That's really helpful. And the other one is making business cases for flexibility and passivity. Then failure factors in this area are not making a decision on the success criteria and the process early on. So if you don't decide on these things with the whole team together and you change it during the lifetime of a project, then it becomes very complicated. And the fifth and last essential is traditional ownership. Keep it simple. And what we've seen in all the initiatives is that, the cases, is that they actually use a regular mortgage. And there are many different ways of financing it, or maybe leasing parts, or co-owning it. But we found that often it was decided, even after considering, that a mortgage was the way to finance it most financially feasible. Because the rents are very low, and if you basically outsource the ownership, then the interests go up. Success factors here is really conscious consideration of the added value of alternative ownership. And you can look at the different building layers here, because they are a good indication of where you make a separation of ownership and how you arrange this, and then keeping it simple. So as mentioned, mortgages are often a good way of financing it, but also deposit systems for suppliers, so that they, at the end of the lifetime, or the lifetime of this building, take back the product and pay you a deposit for it. Then factors for failure is using alternative financing methods for the sake of doing something exotic. Because you really have to look at the function before you determine the form. And then creating an unworkable legal construct. So these collaborative ownerships can be a crucial way of solving in some cases, a thing, but it can also make it very complicated. So be considerate here as well. So to wrap up, I want to give you an overview of all the 5 essentials. And the question is, what is essential in realizing affordable and feasible circular bio-based construction initiatives? Our main question. Then affordable. Did we search for cost-effective and inclusive reuse? Flexible. Did we look beyond the current needs and prepare for future functions and users? And the third one, passive. Did we search for a passive way to stay cool and healthy with bio-based materials? The fourth one, integral. Did we broaden our perspective and continuously reflect on the financial and non-financial benefits of circular bio-based construction? And the fifth, traditional ownership. Did we keep ownership as simple as functional? Looking ahead. So there is more evidence coming in for creating passivity with bio-based insulation materials. And this is something I'm also personally contributing to. With Avance, we're looking into a combination between the hydro specifications as well as the thermal specifications, because usually they are researched separately, while bio-based materials really have an advantage in the combination of the two. And even though we observe traditional ownership in all cases, in the CBCI project we're working on, we have a living lab in KU Leuven, where we also explore leasing out of the HVAC system specifically. So this is kept as a separate layer, but here is a different way of financing it, because in this specific case, that is something interesting to look into, because the lifespan of this building at this location is 5 years, and then it will be demounted and replaced. And this HVAC system is something interesting to look into leasing. And then the question for you is, do you have any questions for us? So thank you for your attention.